Okay, so you probably know what the distance formula is, right? Somebody could probably regurgitate it back to me. But I'm guessing you never really learned where it came from. So we're going to do that today, aside from defining a couple terms and doing some general geometry stuff. Starting early, however, with the Pythagorean theorem. Pythagorean theorem. Okay, so hold on, let me back up. I've tried to design this course so that we work through the terms and only use the terms that we understand. So for instance, at this point in time, if I was to use the word rectangle, that theoretically wouldn't make any sense to us because we haven't defined a rectangle. We've only used words like line, plane, point, line segment, those kind of things. This is where I'm going to kind of violate that rule. Because we want to start doing Pythagorean theorem calculations early on, we have to pretend that we know certain words. For instance, you all know what a triangle is. We haven't defined a triangle yet. We will later. Let me rephrase that. You haven't defined a triangle yet, but you will later. For now, is it safe to assume that you all have a general concept of what a triangle is? Awesome. Do you also have a general concept of what a right triangle is? Good. So we're going to proceed with that assumption. If you have a right triangle, then we can apply the Pythagorean theorem to it. And what is the Pythagorean theorem? Michael?
A squared plus b squared equals c squared.
Technically speaking, no. But that's what, if you stop any schlub on the street and say, what's the Pythagorean theorem? If they paid attention in school, they would tell you a squared plus b squared plus equals c squared. That's actually the Pythagorean theorem. Don't write it down. You know this already. The sum of the squares of the measures of the legs is equal to the square of the hypotenuse. That might not even sound like English to you, but that's okay. And again, we're operating on an assumption that we're good to go with the terms. However, in that definition, there's a couple things that I have highlighted. One in particular is a right triangle. We talked about that already. Then that other one is hypotenuse. What's a hypotenuse? Longest side on the triangle, or the side across from the right angle. When you have that set up, and assuming that your sides are labeled the way they are there, you get that. Okay. And again, that's what most people know as Pythagorean theorem, but what if the letters are different? So I don't want you to just memorize a squared plus b squared equals c squared. I want you to understand how it applies. Take the two shorter sides, square their values, set it equal to the square of the hypotenuse. You have three variables in that equation. In order to solve it, you need to know two of the three variables. So you need to know a and b to solve for c. You need to know a and c to solve for b. You need to know b and c to solve for a. And you've done this before, right? Awesome. So we're going to take that idea of Pythagorean theorem, and that's why I'm introducing it now, is because we need it to do the distance formula. And again, I'm not a big fan of just giving you stuff to memorize, so I want you to understand where the distance formula comes from. So I'm going to start with 2 points on the coordinate plane. It doesn't matter where they are, they're just any two random points. I called one x1, y1, I called the other one x2, y2. It doesn't matter that in my picture they're in the first quadrant. They could be anywhere, and in fact I probably should have gotten rid of the x and y axes so that we didn't have any bind or any ties to that. So we want to find that distance d, right? Because that's what a distance formula does. It calculates the distance between 2 points on a coordinate plane. In order to do that, I need to know how long is that red segment. Now you might be saying to yourself, let's see, 1, 2, 3, 4, 5, 6, and then a little bit, so maybe 6.5 squares. That doesn't work because they could be points anywhere. So instead of asking how long is that red segment, I want to know how would I go about finding the length of that red segment. And this is key to the distance formula, so I'm not giving you this one. You got to work for this. How long is the red segment? Paul?
However long the y is for y.
You're on the right track. Yep.
You subtract y2 and y1.
which one do I subtract from which one? Is it y1 minus y2 or y2 minus y1?
y2 minus y1. y1 minus y2.
There you go, you had a 50-50 shot. Okay. Why y1 first? Because it's the larger value. Okay. Hi,
Hi, Michelle.
Michelle. Remember, keep your guard up. Watch the right jab. Okay, so since Deb has been kind enough to tell us how long the red segment is, he's also going to tell us how long is that blue segment.
x1 minus x2.
Beautiful. Okay? That's a key point. Everybody good with that? So let's suppose this was at 7 and this was at 3. Well, 7 minus 3 would tell me that that distance is 4. Let's suppose this is at 12 and that's at 2. 12 minus 2 would give me that distance of 6. Okay, we good? What kind of triangle is that? And what did we just learn is true about all right triangles?
They have hypotenuse
And?
and two short sides
And? Everything you said is 100% correct.
and the right angle
And? Good?
and the distance formula
No, we're getting there.
and the line.
How about the theorem we just learned?
Pythagorean.
Pythagorean theorem applies. Okay. Since this is vertical and this is horizontal, we get a right angle down here in the corner, which means that this is a right triangle, which means that Pythagorean theorem applies. So if Pythagorean theorem applies, it means you take the shorter side, well there's a short side, y1 minus y2, square it. Take the other side, short side, and square it, x1 minus x2 quantity squared, and that's going to be equal to the square of the hypotenuse, d squared. But we don't want d squared, we want d, so we take the square root of both sides, and we end up with that, which you know is the distance formula. So you've seen this before, correct? Good. You probably just never knew where it came from. You were just given the value and then you plug and chug numbers into it. But now you have an understanding of where that formula is derived from, which will help in your understanding when you're solving those problems. For our purposes in this class, distance is always positive. That's not going to be true in every class, but for us, distance is always positive. So when you take the square root of the number, technically you get two answers, a positive and negative. We're only going to take the positive answer. And make sure you have it copied down correctly. If you're still shaky on it, make sure your signs are correct. There's minuses inside the parentheses, a plus in between the parentheses. Okay, we solid? All right. Let's go back and do some Pythagorean theorem examples, if my clicker works. Find the exact distance between those 2 points. Now, before you get started, let's do this one together, and then I'll cut you loose on one on your own. Which one do you want to be x1, y1, and which one do you want to be x2, y2? x1, y1 or x1, y1? This one? This one, x1, y1. Are we all in agreement?
Yes.
I guess the important question is, does it matter?
No.
No, we'll get the same answer. So we'll make that x1, we'll make that y1, we'll make this x2, and we'll make that y2. Okay, distance is equal to the square root of what minus what? Give me some numbers. -3 minus 4. Quantity squared plus
-5 minus -6.
quantity squared. Common mistake that people make when they start doing distance formulas, they take -3 minus -5 and 4 minus -6. Don't do that, that's wrong. Square root of -3 minus 4 is -7, squared is 49. -5 plus 6 is 1, squared is 1. Sure enough, we get the square root of 50. Gee, why did we do a radical review? What's this simplified? 5 square root of 2. Good. Or if you prefer square root of 25 times square root of 2, which is 5 square roots of 2. Regardless, we get to that final answer. And notice, exact distance, so we leave it in that form. Which is not the most practical answer in the real world. You're not going to go to a Home Depot and ask for 5 square roots of 2 yards of rope. Okay, you'd be laughed out of the store. But for our purposes, it works just fine. Okay, easy? Awesome. Can I erase?
Yes.
Was that a no?
Yes. Yes.
Yes, it was a no?
Yes, it was not a no.
Yes, it was not a no.
Erase.
What?
Erase.
Erase. There's no no's there.
No, no.
All yeses?
Yes.
Good. Just wanted to make sure, because I can't bring it back. Okay, you do this one now, but notice it asks for the approximate distance. So when you're done, take that radical, plug it into your calculator, and round it to 2. Not 1, not 2. Sorry, not 1, not 3, but 2 decimal places. All long weekend to shop for calculators. That'll be exciting. As always, when you get an answer, check with your neighbors to make sure he or she has the same answer. If not, figure out who made a mistake. Hopefully it won't turn violent. Anybody else get the same answer? Check.
I'm still working on this.
Check with somebody.
No.
Do it.
Do it.
I don't know. The blue is pretty, I mean, this is
Yeah, before.
Shazam. But again, clashes with my outfit today.
True.
Yeah.
Usually on black. Sorry.
Sorry, it's okay. Bust it out. Approximate answer. Quick slide. Check with somebody.
Oh,
Same answer. Good. 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 It's set for blue. If you'd like a different color, just tap on the square that you'd like. If you prefer red or black, the green's a little hard to see, but you're call.
Oh, so you have to do that.
Oh.
Back to the ground. How's your vision now? Headache? Get nauseous? That's a really good sign. Pressure here. How long do you stay no socks?
Yeah.
Day to day? Beautiful. Everybody agree? Golf claps? Anna Marie, right? Anna Maria, okay. I'm going to be a little persnickety here and show you a couple things. I'm going to treat this like if it were a quiz problem, just to make sure. We want to keep things clean here, meaning we're working with equations, so you should have an equal sign for each one of these. And then don't just make your square root magically disappear. Make sure it's in there every time. Other than that, we're good. Okay, 13.93. Any problems? For those of you that got it wrong, hopefully you found your mistakes, and I'm guessing it was probably a sign error, because that's the common mistake that people make when they're doing distance calculations. Okay, we good on distance formula. So again, you're going to pay your dues for a week or so, be able to do that distance formula by hand, and then eventually I'll give you a nice little program which will do it for you. New term. What's a midpoint? Caitlin, what's a midpoint? Could you draw one for me?
Wait, is it the point that's in the middle?
Are you asking me? Okay, so here, come here. I won't hurt you. Let's do red. Draw me a midpoint.
On a line.
Okay. How about some endpoints on that? And let's label the points so we can talk about them. That's a B, I assume, right?
Yeah.
Okay. It takes some getting used to with the pen. So you're saying B is the midpoint?
Yes.
Okay. You can sit down now, because that would be awkward if you have to stand up here. I wouldn't want to do that to you. So what makes B the midpoint?
It's in the middle.
It's in the middle. Meaning what?
It's between.
Am I in the middle of the classroom right now?
No.
Am I in the middle of the classroom now?
No.
How about now?
No.
Would it be like here?
Cause that's a line and this is like.
I don't know. That's what I'm asking.
It's right here.
So what happens is, like we ran into when we were trying to do between this yesterday, we have to be careful about the words that we use. So there's nothing wrong with using the word middle if we all know what that middle thing means. What does it mean to be in the middle of something? Is he in the middle of the row? No? Okay, why not? Vanessa's in the middle. Why?
Because there's two behind her and two in front of her.
So there's the same number of people in front as behind. So he's not, because there's only one in front of him and four behind. How does that translate to that?
There's one in front of the B and one behind the B.
Let's get persnickety here again. How many points on that segment?
3.
Infinite. Yeah. So how many points are to the left of B on that line segment? Infinite. How many are to the right of B? Infinite. So that's going to cause a problem, because if I take a point that we all agree, I hope, that is not a midpoint, are we in agreement that that point M is not a midpoint? Okay, so there's an infinite number of points on this side, infinite number of points on that side, so that doesn't work. We can't use that. Nothing.
Would it be like the same distance from either side?
What are those sides called?
Endpoints?
Okay, so can you clean, you're onto something. Can you clean that up a little bit? So I'll ask the question, you answer the question I ask, which will help you write the definition. What makes B a midpoint of the segment AC?
It says A to B and B to C is the same distance.
Perfect. Are you okay with that? B is the midpoint of AC if the distance from A to B is the same as the distance from B to C. How do we express that easily? Because I'm a mathematician, I don't like to write out sentences whenever possible. How do I express the distance from A to B is equal to the distance from B to C?
AB equals BC.
Beautiful. Oh, there's that green, sorry. Okay. Let me give that to you again. In fact, all I have to do is click after I make that stuff go away. Click. I chose M, P, and Q, but it's the same thing. Okay, well done, Vanessa, nice job. Now we have a definition for a midpoint. It's important that you understand the difference between this, which we did yesterday, and midpoint. How many points are between A and B on Caitlin's segment? Infinite. How many points are midpoints? Only one. Good. Is the midpoint between A and B, or sorry, between A and C?
Yes.
Yes. Good. Are all the points that are between midpoints? No. That's another discussion that we're going to get into a lot, the reversible idea. Are all golden retrievers dogs? Yes. Are all dogs golden retrievers? No. So we'll see that a lot. So all midpoints are between, but not all between points are midpoints. Okay. Well done. So sometimes this writing definition thing isn't too bad. Other times it can be a little nasty. So there's a graphical picture there, which is not much different than what Caitlin drew. We've got a segment, and then the tick marks there showing you in the picture that the segment PM is equal to the segment MQ. Okay, we good? Of course, now that we know what a midpoint is, and we know that the two sides are equal to each other, it allows us to do a whole bunch of algebraic equations similar to what we did yesterday. You can read that, but the simplest thing is to use the formula. How do you find the midpoint of a segment? On a coordinate plane now, you take the average of the x's, the averages of the y's. So remember, adding two things up and dividing by 2 is an average. Take the average of the x's and take the average of the y's. Anybody any idea what time this is over? 53. All right. Nice. In case you couldn't do the math, appreciate that. Okay, let's try it. Find the midpoint. We'll start with an easy question. The easy question is here are two endpoints, find the midpoint. Then we'll change it up on the next one, which will be kind of nasty. But fun nonetheless. Does everybody have the points copied down? Okay, because Paul needed the last slide. Don't be sorry. There's nothing to be sorry about.
Wait, I did have them down.
It's only gonna take seconds.
It's a slide battle. All right, I'll just keep doing this then.
Wait, 2 and 9. No, was that -9?
Yep.
2 and -9.
Right, I'm good.
You're good?
Yeah.
All right, he's good, so we can stay there then. Nicole, what do you have?
I didn't finish the problem.
Okay. Molly, what do you got?
5.5.
5.5 and 3.5? How do we feel about that answer?
No.
No.
Oh, what?
Negative 5.5.
And? Negative 5.5. And? Negative 3.5. You missed your minus sign. Okay. Quick calculation there. Boom. Whoops. Nope. Wrong button. That one, then come here, then go, okay. 3 plus negative 14 divided by 2. In parentheses, because we're looking for a point, 2 plus negative 9 divided by 2. That's negative 11, so you could leave it as negative 11 halves if you wanted to. And this would be negative 7 halves. That's an acceptable answer. But these can convert to exact decimals, so you could convert it to decimals if you'd like, which would be negative 5.5 comma negative 3.5. Okay, good. As you can clearly see. Let's move on. This one's different. Read the problem carefully first, and then I'll help you with it. Because it's a wee bit nasty. In problem number 1, I gave you the 2 endpoints, find the midpoint. That's just an application of the formula. In problem number 2, I'm giving you the midpoint and an endpoint and want you to find the other endpoint. So it looks something like this. We've got L over here, we've got K here, and we've got M here. I know that M is the midpoint. I know that K is 1, 2, and I know that M is 5, negative 6. There's an easy way to do this, and there's a more difficult way to do it. I'll do the more difficult way first, and then I'll show you the easy way. I'm going to call this point L x comma y. If I knew the value of L, then I would take the x value from L, the x value from K, add them up, divide by 2, and that would give me the x value of M. So in other words, I would get the equation x plus 1 divided by 2 would have to be equal to what? 5. Everybody see that? x1 plus x2 divided by 2 equals the midpoint x. The other one would then be y1 plus y2 divided by 2 has to equal negative 6. Solve the 2 equations and go. Paul?
Shouldn't K be behind M since it's 1 and times 5?
Shouldn't what?
On the line.
Oh, I don't care. I'm just doing that. I see what you're saying. If it were on a coordinate plane, yeah, they wouldn't be located there. I just need that as a reference. That's the hard way to do it. When you solve each of these, we get x is equal to 9, I believe. Is that right?
Yeah.
Yep.
And then y is equal to negative 10?
Yeah.
4.
Nope,
No,
it's
negative 14.
negative 14. Thank you. Okay? That's the hard way to do it. Here's the easy way to do it. What did I do to go from 1 to 5?
Plus 4.
Plus 4. Oh, look to get the other one, plus 4. 5 plus 4 is 9. What did I do to go from 2 to negative 6? Down 8. Go down 8 from negative 6. Negative 14. Woo! Same thing. Same. I don't care which one you use. They both get you the results you're looking for. How are we doing so far?
Good.
That's a busy day today.
Lots going on. Might be done to wrap the thing. Oh, one more example. Excellent. All right, now we introduce some algebra here. This will be fun. I would suggest you approach this problem like we approached the algebra ones yesterday. Draw a sketch first, label the stuff you know, set up an equation, solve for x, answer the question. Go. You have 3 minutes. Well, you have 2 minutes because we still need to go over it. I'm going to need the last minute to go over it. Again, start with a sketch. Is it safe to assume you all have a sketch?
Yeah.
Does anybody have an equation yet? I'm guessing you probably did this already. No equation? Hold on. How long is PO?
Don't know.
Yes, you do.
Six.
Tell me your name again.
Emily.
Emily, what do you got?
6 minus 3x.
Ooh. Why?
Because it's the midpoint, so
Eh.
it's the same on each side.
Awesome. Yeah, that's tricky. Tricky. That's a shout out to my homies Run DMC. Anybody? No, it's old school. Run DMC. Does anybody not know who Run DMC is? Oh, you've all just failed the
Oh,
class.
God.
Okay, so you have 3 things to do for homework tonight. Number 1 is to check your 1-2 homework. Come in with questions tomorrow. Number 2 is the 1-3 homework, and number 3, read up on Run DMC. There will be some questions tomorrow in class. You need to know who they are. Okay? Got that? Real quick before you get done, what would our equation be? I got sidetracked by Run DMC. Paul?
The equation would be 14x plus 2 minus 6x.
Equals?
Equals would be
Correct. Or I would have done 6 minus 3x plus 6 minus 3x equals 14x plus 2. Solve for x, answer the question, and notice the question is I wanted to know what PO is. So once you get a value for x, you plug it back in. Okay? I think we are done. Let me check to make sure. Yeah, there's all the work. You should get 0.5. Great. Okay, excellent. We didn't get to that yet. We will later. Have a good day. Bye. Don't forget 3 things on homework tonight. Get them all done.